Welcome! This is lesson 2 on sequences. Yesterday in class, we discovered a lot with arithmetic sequences. Remember, arithmetic sequences are the sequences that add a common difference. Remember, in algebra, we don't talk about subtracting because it's truly adding the negative. So don't get the idea that they all have to go up. Yesterday, we talked about decay sequences that went down as well. So I just wanted to bring you back to our initial layout here on sequences. And remember, we're always looking for the power. That's what we discussed in our little muscle here. Okay, is power. Now we're looking more like muscles. Okay, power, because we can predict things. There are people that make their living off of predicting. In arithmetic sequences yesterday, we discovered the recursive formula. It uses the previous term, the common difference, and here was the formula. I do not want you memorizing that. You absolutely must be able to develop it and explain it. So come see me if you're missing class. We need to spend some time together. And the next is the explicit formula. It uses the first term and the common difference. There's how we came up with the formula. And finally, when we were illustrating on a graph, we found that we had another formula that we could use, and that is taking the common difference, multiplying it by the term number that you're looking for, and then adding to it your zeroth term. And if you weren't in class, that's probably going to throw you off. I apologize. Come see me. Now, today, we're going to change our sequence slightly. Let's, instead of looking at this kind of a sequence, the arithmetic sequence, we're going to do this. We're going to look at 3, 15, and let's make this a 45. Now, how am I getting from one to the next? I certainly am not adding 2. If you're saying, oh, I think that you are multiplying by 5, you are correct, and then you'll see, oh, I made a mistake right there. That shouldn't have been 45. That should be 75. Easy fix. I want to make sure and make mistakes on here. That wasn't intentional. I would never lie to you. That was totally my mistake, but I want to make mistakes on here and not edit it out, simply because in our classroom we don't edit out mistakes. That's when we learn the most. So this is now today what we're looking at, where we're multiplying. Now, does that mean that it can't go down? It can absolutely go down. You just simply multiply by a fraction. So this time we are multiplying. And we don't call them common differences, we call them common ratios. Okay, so today we have a new name for these. These are geometric sequences. We're going to look to see if we can find recursive formula, explicit formula, illustrate them, and all of that. Okay, here we go. So, lesson 2, sequences. Let me go ahead and put that up there. They are geometric. And let me give you a sequence today. Let's go... I really want to give you one that will possibly, well, I'm going to go ahead and give you the growth sequence. In class we'll look at decay. I just don't want to do a fraction thing to you while you're at home watching this, because it might add to just a few struggles to the new learning. So definitely be ready to do decay. Right now we're going to look at growth. And I would have to ask you, how can you tell me that that's growth? Okay, so first thing is, please come to class ready to explain how should you know that that was growth? Next thing, just like yesterday, we can put that into a nice little list here. where n is our position number and f of n is our actual term. So we'll go 3, 6, 12, 24, and we'd say this is first term, second term, third term, fourth term. Now, coming off of that, just like yesterday, we can talk about positions. So if I ask you what the second term is, you could say it is 6. If I ask you what the fourth term is, you would say, oh, well, that's 24. Okay? That just helps us in going into our formulas and being able to understand what we're writing here. Okay? Next thing that we want to look at is, well, let's put them into points. So we have 1, 3, 2, 6, 3, 12, and 4, 24. My curiosity obviously is going to be, well, yesterday we found that arithmetic sequences were linear functions. Okay? Today I want to know geometric sequence is what kind of function? I need to know that. Could you please take these points and graph them? Now, you really do need graph paper. As I explained yesterday, and I handed some out, I need you to be putting these on graph paper. So we're going to go 1, 3, 2, 6. I know, I just told you to use graph paper and then I'm not. I apologize, but I don't have any right at hand, so I'm doing the best that I can. 3, trying to keep my values equal, and 4 is way up here, it's 24. Okay, so we can see it's nonlinear. What do I mean by that? Please write that down in your notes. Be ready to tell me if you know what nonlinear is. Just write nonlinear and you know that you've got it inside of you to explain that. Okay, so going back to this sequence up here, I can see that I'll use, I don't know what I'll use. To get from one to the next, what am I doing? If you said multiplying by 2, I believe you're onto something. Okay, so obviously I'm going to do the same thing that I did to you yesterday, and I'm going to say, well, let's get into the power mode of this, because that's what sequences are all about. Give me the power of prediction here. Now, I do ask on your teams, and I ask in your notes too, that you not just write a sequence, but you kind of build it. So we'll go ahead, we'll go, there's 3. In the next phase, there's 6. Next phase, there's 12. We can see we're building quickly. Let me ask you, if you are working a job, which would you prefer? To have your pay be on a geometric scale or on an arithmetic scale? Let's talk about that. I want to hear that talk in your groups tomorrow. I'm not going to bring it up, so I expect to be hearing it. That shows me that you've been watching the films, and I just want to have an idea of what you guys think on that pay. Next up, we know that we're multiplying to get from one to another. Now remember, that's growth if your common ratio is greater than what? And I haven't gone over this. I think you can think this through. If the common ratio is less than what, it will cause decay. Could you please think about that? Okay, next up, I want you to predict what the, these get big pretty fast. Let's go ahead and do the 10th term. could you please find what the 10th term would be? Well, from yesterday, you might be saying, oh, let me go with a recursive formula, because you know the recursive formula just draws right back in on the previous term. So you'd say f of 9 times my common ratio, which I'll just use r for common ratio. Okay, so in this particular case, f of 10 would be times 2. Problem is, you have to find that 9th term. This becomes a little bit of an issue. We can do it. Persevere. Remember, in math, a lot of it is persevering. So, because I'm calculating in my head, it's time to use a pencil. 3, 6, 12, 24. 24 times 2 is 48. Times 2, 96. Times 2, 192. Times 2, 4, 8, 384. Times 2, 768. Okay. So I know that it's going to be 768, and I find that my 10th term is 16, 12, 13, 15, 36. Okay, so that's recursive. Now you can see the downfall of recursive formula is that we've got to build our way clear up there. But we can go ahead and write it. It is f of n equals f of n minus 1. And instead of plus d, today we're going to go times r. That should make sense looking up here and seeing what we're doing between them. So that's your recursive formula. Now, obviously, I'm going to do the little power play on you and say, okay, find my 100th term. Well, hopefully, what you said is, I need the explicit formula. Because you don't want to go up to the 99th term to get this. With the explicit formula, you know that you're going to use the first term and the common ratio. So, let's go back and redevelop that from yesterday. Here we're at the first term. We always go with an easier problem, so we want to get to the 5th term. And that was 48. We'll just pencil it in there for a minute. Okay, to get there, we multiplied by our common ratio how many times? 4 times. It is 5 minus 1. Okay, that should help us a lot. Considering yesterday, now we know we can take f of 1 times 100 minus 1 times the ratio. Now, yesterday we had a plus in here. Be able to explain to me, just in common conversation, why we switched to the multiply today. Let's develop this formula just a little bit more. So, well, first, would you like to actually explore that out? I think it's going to get really huge, so I'm not going to take time out because I might need, well, no, I can do this. Okay, so it is f100 equals our first term, which is 3 times 99 times 2. Ooh, I'm glad that we did this. Because we can see here that we have an error in our formula, what we're thinking. Let's go ahead and do this. So we have 99 times 2 equals 198. And if we look back at our recursive, this is looking a little bit similar. And we're going to see 3 times 198, 594. Guys, I hate to say it, but how could our 100th term be less than our 10th term on recursive? So now I have to go back up and admit 2 times 2 times 2 times 2, we wouldn't just say that we're going 4 times. That is, think back in algebra, I'm so embarrassed that I made this mistake. It's 2 to the 4th. Okay, embarrassment and mistakes, that's okay because it's a safe place. I am publishing mine, so now everybody might think that I'm the idiot math teacher. That's okay with me too, because we just discovered that needs to go into our exponent. I did know that. I forgot that while I'm on film. So let's go back. This would not work. Our 100th term is not going to be less than our 10th term. So now we go F100 equals F1 times R to the 100 minus 1. Now let's calculate this out. 3 times 2 to the 99th. Well, before I can really give you this huge number here, I want to make sure it's right. I want to make sure that I get that 10th term. It's always good to go to something that you know. So 3 times 2 to the 9th. Let's see if we get that. So we grab a handy dandy calculator. 3 times 2 raised to the 9th equals 1536. We got our 10th term, the same as it was in recursive. So now we can go ahead and calculate out this huge number, 3 times 2 raised to the 99 equals, too big to write in that space. Okay, I do want you to know how to plug that into the calculator. I'll show you the answer right there, but you go 3 times 2 raised to the 99 and hit enter, and it gives you this. The E30 means that it's in scientific notation, that it's times 10 to the 30th. So you've got a lot of zeros in there. Okay? So let's get to our explicit formula now. Mistake free, it is f of n equals f of 1 times r raised to the n minus 1. One way that I always remember this formula, so it's kind of funny that I forgot it and made the mistake, is explicit has an exponent. Okay? Explicit exponent, recursive, recurs previous. Okay. I do want to talk about why the recursive switched to a times on this and why the explicit switched to an exponent. So come into class ready to discuss that. That's the end of today's notes. Have a good one.